All right, continuing 6.1. The last thing in 6.1, IoT. Who remembers what IoT stands for?
Internet of Things.
Internet of Things. What's an example of something that would be Internet of Things?
Ring.
Smart fridge.
Alexa, smart fridge, ring camera, thermostat. Good to go, right? Now, for security, IoT devices should be on a separate what?
VLAN.
VLAN or network, right? But the virtual LAN, right? Because of the inherent lower security of these, because the consumer market just makes these devices that typically aren't connected to the internet and allows them to connect through the internet. Now, there's two types of IoT Internet of Things standards we talked about. What's one? One's got an IEEE standard. I heard Z-Wave, I think.
Yeah.
And Zigbee. Which one has the IEEE standard?
Zigbee.
Zigbee, which is IEEE 802. 11's wireless.
15.4.
15.4. And we talked about how many devices Zigbee and Z-Wave can connect. They're both very low data rates, right? No, you're thinking Bluetooth. 65,000 for Zigbee. Still think about all the smart light bulbs and things, right? The low data rate, because you're not going to stream a movie to your smart thermostat and stand there on your Nest thermostat and watch a movie, right? Just enough data to communicate the status, change the temperature, etc. Good to go?
Yeah.
All right, we'll scroll down. We're not going to do this packet tracer, so we're going to scroll down. And we've already talked about Zigbee and Z-Wave, so I think that is it. Any questions on 6.1? Okay. Nope, 6.2.
But we could watch Netflix on our thermostat if we wanted.
Hypothetically, yeah. So this 6.2, that is the end of the chapter. We've got our common troubleshooting. So who remembers the troubleshooting steps?
Identify.
What's our mnemonic? I eat tacos every 5 days. Front row, what's the I stand for? Identify the problem. Second row, 2. Establish a theory of probable cause. Row 3. Test the theory. Row 4. Establish a plan of action and implement solutions. Row 5. Verify full system functionality. Row 6. Document, document, document. Who ya? We gotta know these. We know it comes at the end of every chapter. Good to go? Moving on. We've already talked about open and closed-ended questions. We can keep skipping this. We've talked about these. Common causes for network problems: loose cables, improperly installed NIC if it's not seated or installed properly. If your internet service provider is down, maybe you've got a low wireless signal strength. You need to put up another access point. Maybe your IP address is wrong. Your DNS server or your DHCP server has an issue. If my DHCP server has an issue, like I'm using DHCP and I can't communicate with the DHCP server, what will the first 2 octets of my IP address be? 169. Dot. No. 254. Whatever, whatever. What kind of address is this?
A PIPA.
A PIPA, automatic private IP address, aka link local. Might as well do port numbers. DHCP port number is 6768. Which one's for server? 67. Easy day? All right, testing the theory. Check the cables. Reseat we talked about. Awesome. Moving on, establishing a plan of action. We've already talked about all of these places you can go to research the problem, the logs, manuals, tech forums. Verify full system functionality. What command can we do on a Windows device to verify if I have a valid IP address?
Ping.
ipconfig space/all will show my IP address, right?
I know that.
What about if I want to renew the DHCP process?
/renew/release /release.
ipconfig space/renew or release renew. Good to go? And of course we know about ping as well, which we did a bunch of yesterday. All right, let's test our understanding. All right, what is step 1 of the troubleshooting process?
Identify the problem.
Identify the problem. Number F. Letter F. Step 2.
Probable cause.
Let's do that again. What's step 2, everybody? Establish a theory of probable cause. 3.
Test the theory.
Let's do that again. What is step 3? Test the theory to determine the cause. What is step 4? Establish a plan of action to resolve the problem and implement solution. Step 5. Verify full system functionality and, if applicable, implement preventative measures. And finally, step number 6. Document. Who ya? Good to go. Questions? No? All right. Moving on. Now, the fun part of the chapter. Common problems and solutions. All right, so there is an LED on your NIC. One can indicate that it's got power. The other can indicate if network activity is occurring. If those lights are not lit, it could be because the cable is unplugged, or maybe that cable is damaged, or you want to reconnect that cable or replace it. It could also be that the NIC is damaged. If that's the case, you need to replace that NIC. Easy day? And we made cables yesterday, so we know how to repair cables now. Good? All right, next. Oh, you have an IP address of 169.254. What protocol am I attempting to use if I have a 169.254? DHCP 6768. So I'm trying to use DHCP, but for some reason it's not working, right? Okay, so it could be the network cable is unplugged, so reconnect it. Then do ipconfig space/release and renew. Maybe the router is powered off, or that connection is faulty. Well, turn on the router and do the same thing, ipconfig release renew. Maybe the DHCP server isn't operational, restart it. Or it could even be that your NIC is damaged, so replace your NIC, or a plethora of other things. Easy day? Awesome. Advanced problems for network connections. You can connect to a device with their IP address, but you can't get there with their URL or their host name. What protocol are we talking about here?
DNS.
DNS resolves URL to IP, right? What's the port number for DNS? 53. TCP or UDP? Both, right? Okay, so the problem here is maybe you're putting in that host name or that URL incorrectly. So then use the correct one. Maybe your DNS settings are incorrect. And yesterday we manually put our DNS server IP address. I imagine a few people in here probably typed the wrong thing, right? Then DNS probably wouldn't work. So make sure you've got that correct one in there. Or maybe the DNS server is down or inoperable, so you want to restart it. Good to go? All right, next we have an IP address conflict message. This is going to be a problem you're going to see every day in CCNA. It could be, oh, this IP address already exists on the network, or it's an invalid subnet mask. So if that IP address already exists on another device, well, did you give that computer the wrong IP address? Or are you trying to configure this computer with the wrong IP address? So figure that out first. Now, if this computer, you put the IP address that was supposed to be on here, well, then you try to put it on here, it's going to give you that error message. No matter how many times you try to do that, it's not going to work. So you first have to remove or fix that first computer, and then on the one that's correct, fix it. Good to go? We'll see that in CCNA. A device has network access but does not have internet access. What does that mean? That means that they can get on the shared drive, they can access the resources within the network, but they can't get out of their network to the internet. So what do we know about that? I can communicate locally but not remotely.
Something's wrong with the router?
The router, aka what do we call that IP address, how we get out? The default gateway. So that gateway or default gateway is incorrect, so make sure it's correct. Maybe your router's configured incorrectly, and we'll learn how to correct that in CCNA. Or it could be your DNS server as well, so fix that. Easy day? Questions, comments, concerns? All right, next. Users are saying they've got slow transfer speeds. Their signal is weak. And their wireless goes down, it comes back up, it's intermittent. Sometimes it works, sometimes it doesn't. Well, maybe wireless security has not been implemented, allowing different users to get on the network. Well, then you may have too many users, or there's a lot of traffic on the network utilizing that bandwidth. So implement security. If there's too many users connected to an access point, you may need another access point. Figure out where that needs to go, or a repeater to increase that signal strength. Let's see, we also have, maybe you're too far away from that access point. Well, move that user closer, or add an access point that's going to give them the signal strength that they need. Good? And it could be interference from other sources. What channels for 2.4 gigahertz wireless should we use to avoid interference? 1, 6, and 11. Remember that from yesterday?
Yes.
There we go. So that's what that's talking about there. Moving on. Here are FTP and secure connections. So if you cannot access a specific HTTPS site, what's the port number for HTTPS?
443.
443. What is port 80?
80.
80 or 8080 is HTTP. So maybe the computer is using an allow list, and that specific website's not on that allow list, then right, you want to make sure that it is on there or that certificate is on there. Good to go? Using network tools. Maybe you can't ping a device on another network. Another network, we're saying a remote network past our router. So maybe there's a broken link between yourself and that router. So you could use the trace RT or traceroute command. What ping does is it goes to that device and comes back. Traceroute will go one router out and come back. Go 2 routers out and come back. Go 3 routers out and then come back all the way until it gets to its end device. So then you have a list and you say, oh, that first hop or that first router was good, the second one was good, and oh, not after that. It'll allow you to determine where you need to start troubleshooting. Maybe ICMP is blocked. Well, why is ICMP relevant? That's because ping and traceroute are an ICMP protocol. Hooyah? Yeah. Just like that, right? That's kind of like ping. Those are ICMP protocols. So maybe it's blocked. We'll talk more security-wise why we would want to block ICMP messages. Why do you think a device may want to block ICMP?
Be like for DDoS, like you get flooded.
Yeah, for security, for DDoS, Chang? Hackers. And that's because in that response, it's going to include information,
Yes.
ports, IP address, etc. So they may just, oh, not respond. I don't want you to know if I'm here or not, or any information. Good? We'll talk more about that in CCNA. And it can be blocked at the firewall is where they could implement that. And we talked about firewalls yesterday. Good?
Good.
Next. All right, you do ipconfig /release or ipconfig /renew. That'll initiate DORA, discover, offer, request, acknowledge, which is DHCP, right? And you get so you do those and you get it. The operation failed. That's no adapter is in the state permissible for this operation? Well, that would mean that you've configured your computer statically with a static IP address. DORA, ipconfig release renew, that's for DHCP, right? But if you configured it statically, that command's not going to work because you're not using DHCP, you're statically or manually configuring your IP address. So you fix that by enabling DHCP. Good to go? Easy day. And keep scrolling down. Are there any questions on chapter 6? No questions?